304 quiz, key features of functions. So we're going to talk about interval notation, some definitions, and what's happening on our graphs and on our functions. Think of this as just an exercise in practicing reading graphs and functions and being able to look for the changes. That's all we're doing here. In real life, you're going to see graphs that you'll want to interpret, and this skill is kind of preparing you for that, okay? All right, here we go. So the first question is talking about which interval is the function positive. So before we even look at interval notation, which is just a separate way of describing things that are how things are changing or over the course of this between here and here, an interval, right? Between the ages of 16 and 25, if you own a motorcycle in that interval, there's a high death rate. So that's just an interval. And we could do a notation of 16 square bracket, comma, 25 square bracket, and that would tell you the age range. Does that make sense? So it's not the same as an ordered pair. We'll talk about intervals in a second, but first let's go over here to the graph. Okay, so now it's asking us to figure out where, for which intervals, which we'll talk in a second, is the function positive. Scroll down. Okay, so let's take a look at this. Actually, I want to look at a different variation. Let's look at variation 1. Is the function negative? Yeah, okay, very cool. Let's look at this one. Now we're looking for which intervals is the function negative. Well, we need to decide what does that mean? What does it mean to be a negative function, or where the function is negative? Well, remember, a function is the y values. So if the function is negative, it's going to be less than 0. Well, here's 0 on the y-axis. That means all of the pieces of the function below the x-axis. As we go down here, it's negative. So that means, let's highlight it in purple. Boop, boop. It's negative. Boop, boop. It's negative. So for the purple section, the function f of x, the y values are negative, or specifically less than 0, because that's how we would describe a negative number. Okay, so let's talk about the positive. Where it's positive is just like you think, above the x-axis. It's the places it's not negative, right? So if it's a positive function, we would say f of x, the y values are greater than 0. Think about that. Get that kind of in your mind. Basically, above the x-axis is where the function is positive. Below the x-axis is where the function is negative. So now let's talk about interval notation. We'll look at this blue portion really quick. We go right here at -4. That's -4, up, down, that's 0. So the function is positive in the blue portion. On the interval, we're going to use a parenthesis, -4, comma, 0. We have to use a parenthesis because that's now an interval, and not a square bracket, which we will in a second, because that's where it's 0. It's exactly equal to 0 right there as it crosses the x-axis, and 0 is neither positive nor negative. It's just 0, so we exclude it from our interval. Over here, where it's positive, it's at 6. Oh, okay, so that's going to be a parenthesis, our lower bound, right? The left side is our lower bound, comma, up to our upper bound, boom, 8. Well, it's not on the x-axis, so we can actually include 8. 8 is a value where the function is indeed positive, right? It's above the x-axis. The function actually equals 2. Just, right? Graphically, we'd say f of 8 equals 2. I don't know, that's just a thinking how to read graphs. F of 8 equals 2, because the x value is the input, the y value is the output. So you'd plug in the x to get the function to equal the y. Okay, now where ours isn't asking for that. Ours is asking for when is it negative. So let's do that. Okay, look, this -6, we get to include it. -6, comma, up to -4, parenthesis, over here, 0, down, up, comma, +6. That's where our function is negative. Pretty cool, though. For question 1, no matter which variation you have, the interval notation is kind. You just need to look at the x values for whether yours is positive or negative, what they're asking you. So then you go look over here and you think, okay, I go from 4 to 0, from -4 to 0. So you go find it from -4 to 0. I go from 6 to 8, from 6 to 8. They already choose the right type of bracket for you. So that's not as important, but I wanted to talk about it. All right, think about this, rewind it if you have any questions for a different variation, okay? Question 1. Question 2. What is the relative maximum of the function? Okay, relative maximum, relative minimum is just the y output that's the smallest or the largest. So we'd have, here's a y output, the relative minimum, boop, -2. Okay? So you come down, you find your relative min, you go over to the y-axis and you identify it, and that's what you type for question 2. Because it's just the smallest point or value given your graph in this case, right? That's it. Or if it's the maximum, it's just the most value that you will have given your graph. Sometimes they'll give you on a specific interval, and then you'll have to kind of look at that interval and like where's the highest or lowest, and it could be an end point. It could be an end point, but we're not talking about that today. For which intervals is the function increasing? All right, so now this is different than negative and positive. Increasing and decreasing has to do with our movement of the graph. So let's see if this makes sense. If we are, what are we looking for? I already forgot. Increasing. Okay, if we're increasing, as we move right, we move up. So we have a slight upward motion. Yes, I'm still here. What are you doing? Click. Yes, I'm still here. Oh, there you are. Okay, right? As we go right, we go up. So let's start here. We go right and we go up. Boop. Okay, now we're going down, so that's not increasing. Oh, now we're going right and we're going back up. So now we're increasing. Oh, now we're going down. So we're done. This interval, well, this is an arrow. That's important. That arrow indicates it's going to keep going forever. So when you have an arrow on your graph, you have to notice, all right, that doesn't stop here at -10 or whatever that's there. It's going to keep to -infinity, and we can never catch -infinity. Comma, we are increasing all the way up to 0. We use a parenthesis here because it flattens out. Sorry, it flattens out right there. It's flat, so it's neither increasing nor decreasing. Okay, then over here, that looks like it's halfway between here. 0, that looks like a 1 to 2. So it's also increasing from 1, 2. Let's go see if we did it. Nice, we did. Let's talk about decreasing, since it's the same concept, just backwards. Notice if we're decreasing, as we go right, we're kind of slanting down. So we start here. Let's see. We're going down. Okay. Down. So the opposite intervals, as you can see, so from 0 to 1, we would be decreasing. From 2 to infinity, we would be decreasing. Okay, think about it, pause it, replay it. That's the idea. The definition is for f of x values that increase while x increases, then it's increasing. For f of x values that decrease while x increases, then it's decreasing. And it's just kind of looking at the change as you're moving right on your graph. Okay. All right. I'm going to have to pause the video so I can get ready for my next class. So we can talk about questions 4 and 5. So I'll go ahead and pause this and I'll resume it after class. Boop. All right, you guys. So I'm on question 4. We're talking about interval notation and how to describe functions, right? Okay. So we want to know, where is this, what interval is this function constant? Bust out my colors again. We have this, it's going up, okay. Over here, it's going up. Those arrows are important because that's saying it's still going, like it doesn't stop there. It's going to negative infinity or it's going to positive infinity. And then here, it's going down, and it stops, and then suddenly we have that area that's quite suspicious. It's flat. It's Flat, it's constant, it's not changing, it's not increasing, it's not decreasing, it is constant. So then interval notation, again, we're going to look at the x value. So that's a 2 to a 6. So the interval that this is flat is parenthesis 2, comma 6. Don't worry, you're just looking for the 2 and the 6. They do the parentheses for you. Each interval represents a different thing happening on our function. This one's asking for when is it constant. What that means is on this interval from x, the lower bound 2, as we travel along the x-axis up to 6, so 2, 3, 4, 5, and 6, and all the decimals in between, the function doesn't change. It's constant. So like this, f of x on this interval is equal to -2. That entire time. -2, -2, -2, -2. Oh, now we're increasing. Yes, I'm still here. I'm clearly clicking on the screen. Okay. Anyway, so that's how you would identify when when your function is constant, when it's increasing, decreasing, constant, and then interval notation. Remember, x values, that's the lower bound. We slide up to where it stops. That's the upper bound, and I have a fly in here. So from 2 to 6, this one is constant. Look at your variation. Find where it's flat. Look at the x value and say, okay, it's flat from here to here. That's the interval you're looking for. Question 5 has to do with, oh no, I exited out of it. All right, that's okay. We're gonna go take a look. Question 5 has a definition of even, odd, or neither. In those definitions, it has some very specific things that we're going to look at. So I'm going to go pull up the Desmos that I created for you guys, and I gave it to you in class. Oops. I'll put it in this link of this video as well, so you should see it in the description. You might have to highlight it and paste it into the browser because it doesn't let me put live links or something. This was from a student's question, so I really love your questions that this was developed. Without you, I wouldn't have thought of this, so thank you so much. Feel free to email, call, text with any questions you might have. But really, not knowing something or not understanding something is fine, totally normal. Asking questions is a superpower. So try to dive in there and start slowly asking me some questions because I do love them. So that it's nice to get used to it in a positive environment. You won't always have that reaction in the world we live in. Other people might not react the same way to questions as I do, but they're so important to your success and yeah. So, all right. And whatever you accomplish, even functions are symmetric about the y-axis. So visually, we would have liked to think, okay, it's symmetric about the y-axis. So like if I held a mirror, it'd be the both on both sides. Whoop, whoop, it's the same. This visual, I do like visuals, but this one tends to confuse me when I think of even and odd or neither functions. I start to see symmetry where there isn't symmetry. I second guess my symmetry. So another way to think of it is if we substituted -x in for x, everywhere you see x, would it be exactly the same function? So let's click to see if it's true, because that's the definition. An even function is symmetric about the y-axis, and if you substitute -x in, you get regular f of x. See, they're exactly the same. The regular function is the same as f of -x. And just since I have you in this video, that's like if we did f of, no, let me just type it. So over there, see we just put a -6 parentheses to the 6th power minus parentheses -x to the 4th power. Look how that's exactly the same as all of them, right? Same as the orange, same as the blue. They're the same. That's what that means when we substitute in -x. Okay, and that's an even function. They'll be exactly the same for all of them. Okay, all right. So that one's even. If you have an odd function, something else will happen. Let me turn these off. The odd function is symmetric about the origin. So here, let's take a look at this one. This one is odd. It's symmetric about the origin. This is still something that I may not explain very well. And if you just see it's symmetric about the origin. So if we like folded it, they would fold onto each other. Would we like twist it? I think we twist it and it folds onto each other. So that's what we mean when we talk about symmetry, is that we can do some sort of movement or match the points and they're going to be the same. I'm sure there's a formal definition that I could explain better, but again, it confused me. So this is a great way algebraically and using technology to check it for ourselves. When we substitute negative x in for everywhere we see x, it's an odd function if we get negative f of x. And I'll show you that algebraically in a second. So here we go. We're going to get a different graph. It's not going to be the same because it's not an even function. If it was an even, we'd get, boom, exactly covering our red graph. We don't. But it's an odd function if g of negative x is equal to negative g of x. Notice they're different. It means something different. Let's see. Boom, same exact graph. So this is an odd function, and visually that's what's happening. Okay, so algebraically, what's happening here is we're plugging in negative x to the fifth plus 2 times negative x. And that's what's creating this g of negative x. And it just happens that it's equivalent to negative g of x. So watch what that looks like. That looks like this, is if we just did a negative parentheses around this whole thing, it's exactly the same. So there's kind of the algebra behind the function notation. They're all exactly the same thing. Boop, 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 right? They're all behind this giant purple graph. That's an odd function, and there's the algebra and the function notation of what's happening if you have an odd function. And then we have our neither. It's neither symmetric about the origin, nor is it symmetric about the y-axis, and you won't have any type of nice matchy graph. So here's our original one. There it is, looks like this. So if it was even, when I turn this one on, we'd get the exact same graph. We'd get the exact same graph if it was even. Ready? Nah, it's different. Ooh, it kind of looks odd. But if it was odd, h of negative x will be negative h of x. So then we should get the exact same graph over here. We get 3 different graphs. They don't have the definition. It doesn't have any type of symmetry, and it doesn't have that nice little negative relationship where either it just gets right back to the same graph or we get a reflection. Okay, I'll try. I'm trying not to use those words. But indeed, that is what's happening here. Remember, we have a reflection across the x-axis versus a reflection across the y-axis. And I might say that backwards, friends. Pull up our notes. I very well may have said that backwards, but again, we have notes on what is happening here, and we could try to evaluate what's happening when we do that. I bet we could figure it out by turning it on and off, but I'm not going to do that in this video. Feel free to use this exploration and do that yourself to decide, was I right? Is this the y-axis? Is this the x-axis or not? And you're looking for the reflections this way and this way. And you can change the color here. One last thing. You can't see it. You can make it orange. Hold it down. You can make it blue. Make it purple. And there you go. So you have different colors of the graphs. So this one, yeah, maybe you have to zoom in some more. Okay, like I said, I'm not going to do it here. Okay, so that really looks like across the y-axis. And that looks like across the x-axis. So I think I said it right. You can go back and check it. And again, I'm looking at this tiny little, teeny tiny detail right here. This little floop and floop. This one we have the orange and the blue. This floop goes over here to the left side. So like a reflection across the y-axis, right? And then when we do this one on, this little floop goes up here. So a reflection across the x-axis. And yes, floop is a mathematical term.